Hi, I'm Alistair, I'm a games designer, and in this video I'd like to show you my clock. This is my clock, and it's a regular wall clock, except I've removed the mechanism from it, and instead I've put in a dual shaft stepper motor. Those shafts are connected to the hour and the minute hand that are on the clock face there, and the stepper motor itself is being controlled by an Arduino. The Arduino has a Wi-Fi module attached to it, which means I can send commands to the Arduino over a serial connection or over a Wi-Fi connection from any other device on my network, and I can instruct it to go to a particular time. That will make the stepper motor shafts rotate and the hour and the minute hands will move accordingly. So at the time I'm recording this, it's just after 9:30 in the morning, it's about 9:31. So if I go to my serial connection and I type in the value 9:31 for example, what will happen is that the hour and the minute hands will rotate independently to get to that time. Now let's say that you wanted the clock to actually move in real time, so every minute you wanted the minute hand to advance. Well, that's fine, you can do that by just sending whatever the latest time you want to update it to is. You can also make the hour hand move independently, so let's say we get to British summertime and you need the hour hand to move forward an hour, but leaving the minute hand the same, that's fine too. So they're completely independent of each other. I just reset that back to the beginning. Now to demonstrate the Wi-Fi functionalities, I've got my phone here, and what's happening is the Wi-Fi module on the Arduino is essentially running a web server. So to send a command to the Arduino, what I can do is go to the website being hosted by that web server and make an HTTP request passing in some parameters of the time I want it to go to. So choose a time, any time. 2:30 in the afternoon. Perfect, let's go with that one. Okay, so I'm going to go to the IP address of the Arduino. I'm going to pass in two parameters in the URL. I'm going to say H is 14, so 2 o'clock in the afternoon, and M is 30. So if I just show you the browser on my phone, hopefully you can see that. 192.168.1.4, that's the IP address of the Arduino. H is 14 and M is 30. And when I click go to that website, what should happen there? There we go. And the hour and the minute hands will move. So you can control it from any device, from a tablet, from a mobile. You can have it triggered from software on a PC, and you can either do it wirelessly like this, or you can have it via a serial connection. So that's my clock. Thank you very much for having a look at it. Now I'll show you how you can make one yourself. So here's the hardware I used for this project, starting with the clock itself. Now there's absolutely nothing special about this clock. You can just buy it from any regular hardware or homeware store, something like that. This one came with a mechanism on the back that took a single AA battery. I pulled that out, and in its place I put in one of these instead. So this is my dual shaft stepper motor. Now the particular model I'm using, this one is called a BKA 30D-R5. There are other similar models as well, and I think they're sold for use in the instrument panel on the dashboard of a vehicle or something like that. So it has this dual shaft here. It has the spindle at the top, and then it also has this white plastic bit here, and they rotate independently based on two bipolar stepper motors. So I talked a bit about stepper motors in my last video when I showed a motor that I took out of a fruit machine. This is the same idea, except it has two motors, and they have very thin pins which you might not be able to make out there, but there's a pair of pins here and a pair of pins at the top. They control the two coils of the outer shaft, and a pair of pins here and a pair of pins at the bottom control the two coils of the motor of the inner spindle, like that. Now, and then what I did is once I'd poked that through from the back of the clock to the front, I then attached the hour and the minute hand onto the shaft and the spindle. Now this isn't a perfect stepper motor. It's quite noisy. One of the reasons for that is that inside there's sort of a plastic gear chain, all the cogs that connect the two motors together to feed into this single shaft here. They're quite noisy. I have found when it's running for a while as well, it loses precision a little bit, because probably for the same reasons. although I have got a solution to that which I'll show you in the code later. However, the advantages of this particular unit, the first one, it's very cheap, and secondly, it can run on 5 volts and only draws about 20 milliamps of power. So that means you can run it directly from the output pins of the Arduino itself. So that's really convenient for a project like this. So here I've got my stepper motor pushed through the back with the hour and minute hands on the front of the clock. The stepper motor, I've got those 4 sets of 2 wires going to an Arduino Uno. I've got a screw shield on here just for convenience, but you can use whichever method you want. You can get a PCB in here, use any Arduino you want. And then at the bottom here, I've got, this is an ESP01, and again I've shown this in a previous video, so I'm using this as a method to connect my Uno to Wi-Fi and run a small web server on it so I can control it from a browser on my network. If you're using, let's say, an ESP8266 board here instead, or an ESP32 which already have Wi-Fi on them, you don't need this adapter. Or perhaps you have an Ethernet shield or a Wi-Fi shield as well. They'll serve the same function as this. So the purpose of this is just to enable network connectivity to the Arduino, but there's a couple of other ways that you can go about doing that. So the wiring is actually pretty straightforward. Over here I've got the stepper motor, and I've got this pair of pins at the bottom that are wired to Arduino pins 4 and 5, and I've got this pair at the top that are going to pins 6 and 7. So that controls the 2 coils for one of the shafts of the stepper motor. And then on this side I've got another pair of pins. These are going to pins A2 and A3 and A4 and A5 on the Arduino, so they're coming around to this side instead. Now, like I say, because of the particular stepper motor I'm using, this BKA30DR5, this runs off 5 volts and only draws a very low current. So I've been able to get away with powering this directly from the output pins of the Arduino. But if you were using a different stepper motor, or for sort of best practice, I suppose, what you'd really want to do is have a dedicated stepper motor driver here with a separate power supply, and then just use the input pins here to control the signal. But this works fine for the setup that I'm using. And then over this side, if like me you want to have a Wi-Fi be able to control your program remotely, so I'm using an ESP01, and I've got it plugged into this little adapter board here. Now the reason for using the adapter board is that an ESP runs at 3.3 volts rather than the Arduino, which is running at 5 volts, and the adapter kind of provides 2 functions related to that. The first thing is it provides a step down, which means you can run it from the 5 volt line of the Arduino here. You might think, oh well hang on, there's a 3.3 volt out on the Arduino anyway, so can't I use that? But that won't actually provide enough current to be able to power the ESP01 when it's in full Wi-Fi mode. The 5 volt output here can supply a higher current output. It can supply up to 500 milliamps. So you need to run the 5 volt line, but then the module here will actually step it down to 3.3 volts. And the other thing it does is it converts the logic signal on the receive and the transmit lines from 3.3 volts, which is happening over here, to 5 volts, which is what the Arduino expects, coming in on port 8 and 9 there. So that's the wiring. If you choose not to use a Wi-Fi module like this, if you just want to use a serial connection over USB, obviously you can ignore this section of the diagram completely and just get the stepper motor plugged in. So the code here is reasonably long and relatively complex compared to the code for some of my other projects. And one of the reasons for that is because I've included the code both for setting the time via a USB serial connection, so if you want to type the code in the serial monitor and click send, And also if you want to send the code over a Wi-Fi connection to a web page. So I've left them both in here, partly so that I can show you and compare the similarities and the differences between using those methods, and partly so that you've got the option of which one you want to use. But it has made the code a little bit more complicated. If you only want to use one of those methods, obviously you can delete or comment out the code that doesn't apply to you, which will make it a little bit more straightforward. So I'll try to focus on what I think the main bits of this code are, or any new parts of code logic which I haven't demonstrated before. So start off at the beginning. Obviously we just define a little mode in case we want to do some debug information. Different stepper motors have different number of steps, so they have different resolutions, we say, in terms of how far the motor turns with each pulse. The stepper motor I'm using takes 720 steps to do a complete revolution. So using a little bit of simple maths, you can work out therefore that it requires 60 steps to move forward 1 hour, or 12 steps to move forward 1 minute. You might need to adjust those values if you use a different stepper, obviously. The next thing I'm going to define is a buffer size. Now this is the buffer that's going to store the HTTP request if you use the web server. So let's say that the IP address assigned to the Arduino on your network is 192.168.1.18. So what you're going to do then to pass parameters to the code that's going to set the time is you're going to make a URL request like that. So we're going to pass in parameters. H is 10 for hours and M is 45 for the minutes. Now what the Arduino sees, or what any web server sees when you make a request like that, is a line that looks like this. So it specifies the sort of request. This is a GET request. We're not specifying a particular page, we're just going to retrieve the root of the web server, so we'll just put a forward stroke and a question mark, and then the parameters here, H is 10, M is 45, and finally it always specifies the protocol that's going to be used as well, so we're using HTTP 1.1. That occupies a total of 25 characters, that line there. So a buffer size of 32 should be perfectly sufficient to accommodate that, but I've left a little bit of space at the end in case you wanted to pass any additional variables in as well. It is worth noting, normally in code you want your variable names to be as descriptive as possible. In this case though, because we're actually passing these parameters across a network, I've just called them H and M instead of hours and minutes, just to reduce the total amount of data that's going to be transferred at all. So there we go. Now in terms of the libraries, I'm using a library here called Axel Stepper, which you can download from here. That's just going to make addressing the stepper motors a little bit simpler. I'm also using Wi-Fi ESP, which you can download from here. That's the library that enables us to use a ESP01 module as a kind of a cheap Wi-Fi shield for an Arduino Uno. And one more thing to notice here. So an Arduino Uno only has one dedicated serial, hardware serial, and that's used by the USB connection most of the time. So when you upload or upload code to your Arduino, or when you use something like serial.print to print the value of a variable to the serial monitor, you're using the hardware serial. And that's what we're going to use in this example as well. But we also want to create a serial connection between the Uno and the ESP shield. So for that, we're going to have to add an additional software serial connection. Now, there's a library here called Software Serial, which you might have seen used in other examples on the internet. But I find that this alt software serial is actually a bit more reliable, a bit more robust, and it's faster. So if you're transmitting quite a lot of data, which we're going to be over a Wi-Fi connection, I found that this is a better choice. The only restriction is that you have to use pins 8 and 9 to connect it to the Arduino. You can't assign any pins, which you can use in this one. But I think that's a fair trade-off, so I do recommend you use that library as well. The reason it's wrapped in this just if not defined bit here, So some Arduino boards, like the Mega, have more than one hardware serial connection. So I think the Mega has 3 hardware serial lines. So if you're using a Mega, you don't need to create a software serial for the second connection. You can use one of the hardware ones. Then we go to the globals. So here's just a little pin map again of my stepper motor. So we define one object that's going to be the hour hand stepper, and that's using these pins. We'll define another object for the minute hand stepper on these pins. Then what we do is we have the credentials that we're going to use to attach to the Wi-Fi network, and we create a local server object running on port 80. Okay, so that's the variables. Let's go into the setup functions. So remember not to get confused here. First of all, we begin a serial connection, and that's just a regular serial connection that we're going to use on the PC using the serial monitor in the Arduino IDE to send and receive commands. We're then also going to begin a serial 1 dot connection. So that's either your hardware connection if you're on a Mega, or if you're on an Uno or on a Nano, it's going to be that soft serial connection that I just told you about. And we're going to initialize the Wi-Fi library using that second serial connection there. Passing the credentials that we defined above, and then we're going to wait until we get a message to say that the Wi-Fi is being connected. And when it is, we'll just dump out a little bit of information. So we'll say the name of the network, what the IP address that's been assigned is, and then we're going to begin the web server. And finally, we're just going to do a bit of configuration of the stepper motors. So we'll set the speed and the acceleration for each one. Again, these are values which you might need to change depending on the particular steppers you use. Okay, so we're going to now define a function called setTime. This is actually pretty straightforward. We just pass in an hours and a minutes parameter, print off a bit of debugging information, and then we'll call the moveTo function. So this is a function that's specified in that Excel stepper library, and we're going to move the hour stepper to the specified number of hours multiplied by the number of steps per hour, and we're going to move the minute stepper to the number of minutes times the number of steps in a minute. That's nice and straightforward. Okay, now this function here, this is the function that's going to be used if you want to use the serial input as a method to control the clock. Okay, so if you want to use Wi-Fi only, you can kind of delete this from your code. You won't need to use this. So serial.available will tell us if there are some bytes of information waiting on the serial connection, if it's greater than 0. So something's been received, someone sent a message. We'll define a character array, and we'll just call it data because I couldn't really think of anything else, and it's going to be 6 bytes long because this is going to be hours and minutes, and with a trailing terminating character at the end, so we shouldn't need more than 6 bytes of data to hold 2 digits of hours, 2 digits of minutes, a separator, and an end line character. We'll define just a variable of the number of bytes received, and then what this function here does, so this is quite useful, this is going to read all of the bytes that have been received on the serial connection. So rather than read them one at a time, we're going to read them all until we get to a line ending character, so a character return, and we're going to read them into the data variable, and we're going to read a maximum of 5 bytes, okay? So then what we'll do, so that's the 5 bytes of data. So remember we've got hour, and then a separator, then minute. So that's 5 characters, and then we're going to add a 0 on as the 6th character. So that's going to be a terminate the character string. Is going to be the 0 at the end there. Okay. So we've now got a complete data, which is going to be a time representation in the format hour, minute with a separator. Now, well, I've got a special case here, though, which is if the only thing received in the data was just a minus sign, I'm using that as a kind of a sign to say reset the hours. Remember I said that the hours and the hands can get slightly out of line, and I've got a method to reset them. Well, what I do is when I set the hours back to what I want to be 0 time, so midnight, I'm going to send this minus character as well. So when we compare the binary values of the data received to a minus character, and we only look at 1 byte of data, if there are no differences between them, that's a very complicated way of saying that this is what the value of data is basically, then we'll set the current position of the hours and the minutes to 0. Now note that set current position doesn't actually mean move the hands to the 0 position. What it means is whatever position they are in now, we're going to call that the 0 position. Okay? So it's like a kind of a calibration function. Now it's all very well setting the 0 position. We also need to be able to manually adjust the hands into the right position so they're both pointing at midnight. So what I've done here is I've just defined 4 other single character values that can be sent to the serial connection. So if you send a little h, that's going to move the hour back by 1. Send a big H, it's going to move it forward by 1. A little m moves the minutes back, and a big M moves the minutes forward. So this is my kind of manual calibration function. By sending these values, and then when you get them to be, when you get the hands to be lined up by sending a series of H and M functions, then when you get there, you send a minus to say, okay, they're now at the 0 position again. And this is a way that you can reset the hands if they become out of line at all. Otherwise, if we got past those sections, it means we're actually sending a proper time-stamped value. So this is a little bit complicated if you're not used to using text strings in C, but we're going to use a function here called struct_r, and this is what's called tokenizing a string. So we're going to search through the data string which was received, and we're going to search for an occurrence of a colon, because that's what I'm using to separate the hours and the minutes section. So wherever I find that, I'm going to take the first token, which is going to be the bit that appeared before that, and I'm going to assign that to the hours variable. I'm going to call this struct_l. That's going to take the string value, hh, and it's going to convert it to a long integer instead in decimal. That's what the 10 is there, and so I'm going to call that hours. And then we're going to tokenize the other part of the time string that we sent. So that's going to be the bit after the colon, and that's going to be the minutes. Again, we will tokenize, so that we'll tokenize the remainder of it, and then we will convert it to a long integer in base 10 and assign that to minutes. So once we've done that, so if someone has sent a value over the serial connection that looks like that, we'll split out the hours and the minutes, and then we will call that setTime function, which we defined up here, to set the hours to the right place. Okay, what about if instead you wanted to use Wi-Fi and HTTP to set the hours and the minutes instead? Well, that's what this function does. So again, if what you wanted to do is actually use a USB serial link, you can ignore this section. But it's got some similarities, so it's worth sort of noting what they have in common and where they differ, I think. So just as we checked whether there were any bytes available on the serial connection before using serial.available, the first thing we do here is listen if there are any bytes available on the server. And if there are, that means that a client is connected and has made a request for something. So we'll go into the next section. And what we'll do here, so this is how we're going to pass the request. So the way that an HTTP request is made always ends with a blank line. So to work out whether we've got to the end of the request or not, we're going to keep track of whether we've received a blank line or not. And we're going to loop over the values before we get there as well. This is where we create the buffer that I said about in the beginning, so the buffer that's going to hold all of the characters in the request. And we're just going to track some other variables just to keep track of where we're up to in processing the string as well. So, a little bit like the serial.readUntil we had before, except this time we're actually going to manually step through each of the bytes in the request. And we're going to read them in one at a time. So there is at least one byte to read from the request, and we're going to use the bytes that we've read to fill up that request buffer. When we get to the end, we'll put a trailing terminator on it so that we have a terminated character string that we can look at. If we've got to a new line character and the current line is blank, then that means that we know that we've got to the end of the request, because we've had a new line break and now we've had a new line again. So that's the end of the HTTP request. So what we can now do is we can look through the whole of the buffer and we'll see what that request contains. So just as before, we're going to use the string tokenizing method, except instead of looking for a colon to split the hours and the minutes part, the first thing we're going to do is search for a question mark, because that's what's going to separate the first half of the request from the parameters that we're looking to get to. So we'll search for a parameter. If we've been able to find one, then what we'll do is we'll compare the tokens in the parameter, and we'll say, okay, well, does it begin with H equals in the first two positions? If it does, then we'll take the next two characters and we'll convert them to a long, which we'll assign to the hours variable in decimal, so base 10. If instead we found a token and that token begins with M equals in the first two positions, well, then we'll take the next two characters and we'll assign them to the minutes variable instead. Again in base 10, obviously, because everything we're doing is in decimal. So that's how we set the hours and the minutes here. So similar to how we did it with the serial connection, again we tokenize the request, but this time we're looking for a variable name in the first two characters, because we don't necessarily know the order that the parameters are going to be passed in. It could be hours first, then minutes, or minutes then hours. And we keep on doing that until we've passed all of the tokens in the request. And once we've done that, we send a little response to the client. We'll disconnect the client from the web server, and so long as we've received some valid values for both the hours and the minutes, so I initialize them both as -1 up here. So I initialize these variables as -1. If we've got through the whole of this function and we've got some valid values other than -1 there, we know that we've received them correctly, and so we'll call the set time function with whatever we've received. One of the reasons for including this is that certain web browsers kind of create additional HTTP requests that you might not sort of even know about. An obvious one is that some websites have something called a fav icon, which is like the little icon that appears in the browser bar. So every time you visit a page, the browser will kind of invisibly and automatically behind the scenes also make an additional HTTP request to retrieve that icon. So if that's the case, we're not going to be able to pass a hours and a minutes out of that request because it's not that kind of request, so we ignore that. Only if we've received valid values of the hours and minutes do we then call that set time function. And this just then, so this is if we haven't got to the end of the line, if we haven't got to the end of the request yet, we'll just keep on processing until we are able to set that current line is blank to be true, and that's how we know we got to the end of the request. This is what the web server calls when a client makes a request, and we process a request and we send something back to the client. So this is basically a web page. This is writing a simple web page back to the calling browser. So we'll send a little response to say, okay, we received your request and we're going to send you some HTML back. And that HTML is going to be a really simple web page. It's just going to give some instructions to the client to tell them how to use this page. So we're just going to set a time by calling this page with H&M parameters, e.g. then we'll put the address of the page. So this is an example that will set the time for 1:45, and then we'll just send that back to the browser. And then finally we've made it so all the way at the bottom. This is the main program loop function. So I'm calling both of these functions in the example here. This is the one that is going to check for input over the serial connection in the form HHMM and then you just click the send button at the top of the serial monitor, and this is the one that's going to look for input in the format with a parameter H is 10, M is 45. Sorry, that should be ampersand there. And that, but you might not need both of these. You could see though that there were some similarities behind how they actually pass the input and then ultimately pass them to the set time function. And the last thing we do is actually call the run function assigned to both stepper motors to actually move them to the target position. So in our set time function, which is all the way back up here, this move to function here, what that does is that sets the target position for the hour and the minute hand that they need to move to. It doesn't actually move them though, so it's a slightly confusingly named function. Move to simply says, okay, this is the target position that you should be at. What the run function does is that then looks at where the current position of each stepper is, where the target is, and then based on the parameters that you specified for the maximum speed and the acceleration up here, it then actually moves the stepper the required number of steps in the right direction. So we call that every frame. And if the stepper is already at its target destination, then this function simply does nothing in that frame. And that's it. So perhaps the last remaining question is, why would you want to do this? Well, obviously it's a bit of fun. It's a good way of finding out about controlling stepper motors and about wirelessly interfacing with a device over Wi-Fi or something like that. But there are other applications as well. It's a great use of a puzzle and an escape room or something like that. You can have the hour and the minute hands point to particular digit values. And you can also have an array of analog clocks like this actually make quite complex shapes. If you're interested in that, I encourage you to check out a group called Humans Since 1982, who are an art collective that have done some fantastic installations with huge arrays of analog clocks, making quite complex organic shapes just using the hour and the minute hands to point out in different directions. But I mean, you can use it for lots of purposes. If you have any ideas of what you'd like to use it for, or if you use it in any way, I'd love to see what you come up with. Please let me know in the comments below. But hopefully you found this informative and useful. As always, I'll put links to the code I used and the wiring diagrams up on my Patreon. So if you follow me over there, you'll be able to download them for yourself. And thanks very much for watching.